Okay, welcome back class sa ato ang class on electromagnetism on the topic electrostatics. So I believe this is chapter 5. Sorry. I think this is chapter 5 sa atong module. And nahuman na ta sa electric field, electrostatic field. Actually, human na diri. We are done with the calculation of the electric field by a given charge or a given set of charges or a continuous set of charge distribution. But there are times na using the Coulomb's equation is really quite cumbersome and medyo lisod yun siya actually honestly i-handle. This having to do a lot with the integrals and number 4 pi epsilon naught q and dq over r squared, having to deal with this unit vector quantity within the integrals. Later on, when you encounter with problems na I tell you medyo hassle na siya o lisod siya in a way i-handle. As much as possible, physicists will try to avoid these integrals but still get the same answer. So there could be another technique para ma-solve ang electric field. To get the electric field, to get maybe makuha na to ang charge Q or the total charge Q given the electric field na dili ta mo agi aning complicated na root involving vectors, involving this integral. So for that matter, we'll try to review, revisit, and make use of the divergence and curl. And this time around, i-apply siya sa electrostatic field or electric field. Okay? Let's go back to the definition of an electric field. Electric field lines can be graphically represented by using these field lines. So, representation niya is a straight line, vector, radially outward. And the strength of the field is dependent on the point or source charge present, and ang iyang intensity is mag-differ siya if daghan siya field lines. Mas kusog niya compared aning wala gamay na siya field lines. And the direction of the field lines indicates the direction in which the positive test charge moves when placed in this field. So if magbutang ka diha og positive test charge, it moves in accordance sa in the direction along with this in the direction ang aning field. So diha pud move ang positive test charge. The density of field lines per unit area, so in this case, is proportional to the strength of the electric field. So kung mas dako ang iyang mas daghan ang iyang o dako ang iyang magnitude or value sa iyang density of field lines per unit area, of course, the strength of the field is also greater if you compare this one and this one. So field lines originate on positive charges and terminate on negative charges. So it's like this. If na ako, this is positive and then this is negative. Inaana siya. Right. So you get the idea. And the catch is, ang mga field lines, sorry for this, they never cross each other. Because if mag-cross here, then how will you define the electric field for this particular point, right? So nature has its way. Inani ang nature sa imong field lines. They never cross because it's a field and each point in space is uniquely defined. So field lines never cross. If this would occur, the direction of the electric field lines at that particular point would be undefined, so really is not defined. So take a look at this graph. The electric field lines generated by a positive point charge Q and this is for a positive point charge 2q. So notice the difference, mas dako ang charge kani sa right hand side. So of course, mas daghan ang iyang field lines. The flux of electric field lines through any surface is proportional to the number of field lines passing to that surface. Of course, ang flux niya is proportional siya kung pila kabuk ang ni-pass through sa at pila kabuk electric field lines nilusot given a particular area ani. So kani turo ra ka buok, of course mas gamay ni siya og flux compared to this, mas daghan ang iyang field lines nga nilusot ni pass through sa kana nga given area. And that is also tantamount to unsa pud kadako, unsa pud ang value sa charge niya. Mas dako ang charge, mas daghan ang field lines. Kani pod mas gamay, so lesser ang iyang flux. So consider, for example, a point charge Q located at the origin. So point charge Q located at the origin, the electric flux phi of phi of E through a sphere of radius r centered on the origin is equal to, so if naakoy this one, because naakoy charge diha centered at the charge Q. So we can get the flux if ang imong volume is, say area is a sphere. So na siya flux niya. Right? Flux. So just counting kung pila ka buk electric field lines ni lusot ni pass through sa kana nga surface area. So it's given by this. So the flux is, recall your formula for flux. Okay? It's just the counting tara. Electric field lines, meaning electric field lines dot with your area. In this case, small element. Okay? Small element sa imong area ang ikuha na you sum it up sa tanang katibuk surface. So we have E dot dA. So iharang gikuha ang direction kung asa padulong ang imong perpendicular to that area. So if you have the electric field lines, and this is your area, so ihang i-dot ra niya. Right? Just counting the number of electric field. Let's say, for example, this is your surface area, this is electric field. Of course, you get the maximum flux if ang imong electric field line is perpendicular, right? If not, na siya inani nga angle, ihanang paon is ang iyang kani nga component, kana nga counting. So, paano mo ang theta. Okay? So, that's why you have to dot this electric field line, and then this is dA. Kani ang direction sa dA. So, you have to mo siya i-dot. Right? So, take the dot product. Then the area, the surface area is given by this. The electric field is given by this, and this is your electric field. Right. Well, this one is your dA. So, kani siya nga type of area is sa iyang surface ni siya sa imong sphere. So, kani siya. Naadiri siya. It's given by this formula. Yeah. I think we already calculated this one already sa previous na itong lesson. We have r squared sine theta d theta dp r hat. And integrated over a surface. And since wala man siya in terms of r, just d theta and dp, so r squared will be taken outside. Right? So cancel na siya. Kani po gawas na siya ang cube. So we're just left with this. So cancel integral of sine theta d theta d phi will just give you, separate mo na siya pag-integrate. say integrate ito ang sine theta d theta, integrated from 0 to pi, and ang dp is integrated from 0 to 2 pi. So integrate mo separately, you get actually 4 pi. So this is 4 pi. So mag-cancel na siya ani. Right? So we are just left with q and then the epsilon naught. That's why we have this one. That's why we have this. Q over epsilon naught. Now this is only true if you have one charge sitting at the origin. Now what if, using the superposition of principle, we extend our conclusion, this one, to a system containing more than one point charge. So that's why nanak ko I niya. Pwede Q1 plus Q2 plus Q3. So nanan this here. Right? Same trick or idea as before, mag-calculate ang electric field using point charges. So this is calculating the surface. If you look at this equation, ang counting di ay sa imong flux, which is electric field lines, with respect sa imong surface area, is equal to kung pila ka buok ang, make sense ya, kung pila ka buok charges ang na-enclose niya, ang naa sa sulod, nasa ilaw. Mas dako ni siya nga value if daghan ang imong, or dako ang value sa imong charge, right? Mas dako siya, mas daghan. So that's the idea. It's like na ako'y faucet. Ako'y faucet. O agas ko na siya, agas. Ang counting sa imong flux din at would equal na siya kung pila ka buok unsa pa imong source, right? This is the flux. And this is the source, the charge yang na-enclose. Kung gamay na siya, so gamay na po ang source nimo. The same thing with the electric field. So we then conclude that for an arbitrary surface and arbitrary charge distribution, we can have this formula, equation 5, where Q enclosed is katong isam ni mo tanan, pila ka buok total charge na enclosed sa imong area. So in our case sa kanina, sphere man to siya. Okay? So nag-count ka diha sa electric field lines, ihang flux. That's equal to pila ka buok charge na enclosed given this area. Calculate the flux. So you have Q enclosed. So when Q enclosed is the total charge, right, enclosed by the surface. So this formula is actually the Gauss law, the famous, the popular equation, Gauss's law. So this will come in handy when we encounter problems involving electric field. So it is a lot easier to handle this one, than the Coulomb, right? Later on, ma-appreciate nyo muna siya. So using the divergence theorem, you can somehow rewrite this one. Using the divergence theorem for the electric flux, recall the divergence theorem. This is given in equation 6. The divergence is kanina sa surface equal siya sa kanina integration over the volume. Okay? Recall mo sa divergence theorem. So this is del dot P. But since kanisiya and this one is equal to the integral over the surface is equal to the integral over the volume, this is equal to Q enclosed. Q enclosed. Also, we can rewrite the Q enclosed in terms of the charge density. Wait, kanina kaya ang Q enclosed na to kaya ano ba? Now, considering ang imong source charges kay discrete, in reality, hindi man necessary nga discrete, right? Pwede man siya continuous siya ang most of the time. So, mag-ano na rin ka. Rho, b tau, over epsilon naught. Could be rho, could be sigma for area, or lambda for line. So, let's say volume lang siya, we'll have this. This is katulad kanina nga. Q enclosed, katong source charge lang, have rho data. wala na siya over epsilon naught pi kay kanina atong definition. Ang over epsilon naught is na-separate siya. So Gauss's law can then be written as, using this one, katong sa divergence theorem, katong iyang divergence sa E, d tau, tapos this is the Q enclosed, right? Q enclosed over epsilon naught. Since we have not made any assumptions about the integration of the volume, could be anything, kani ang volume, wala mo talaga assume isa na siya nga klase nga volume, therefore, the integrands must be equal. So, equal ang mga integrands. So, if kani siya kay equal to this integrand niya, then we can drop the integral, we are left with this equation, equation 9. So, del dot E equals rho over epsilon naught. This is the another form of your Gauss's law in differential form. Differential form of Gauss's law. Ganina is katong integral nga form. So we have E dot dA equals rho Q enclosed over epsilon naught. That's it. So that's the equation for Gauss's law in differential form. So take note, masayo na siya isolve, right? Given the electric field, we can get the rho. So we can easily solve for the, unlike bitaw sa katong coulombs, ang coulombs law, we call this equation dq over r squared r hat. So if, or dq is just this one. dq is just rho d tau. Now I want to find the rho given the electric field. It's very, very difficult. Saan mo pagbali ba? From given ang E, paano mo ang rho? Whereas this time, given ang E, we can get easily the rho because we just have to do divergence naman na siya. So we now know this technique, masayon siya mag-solve. Then, using this complicated integral. So Gauss's law in differential form can also be obtained directly from the Coulomb's law for a charge distribution. So given equation 10, using this Coulomb's law, makuha na ito ang Gauss's law in differential form. So the divergence of E is equal to, we get the divergence of E. This is the formula for the divergence. Ang katong R lang ang part ang ikuha because ang whole thing ng R. And take note na kani siya nga equation that's equivalent to this one, the Dirac delta function. And integrating over this Dirac delta function is easy and straightforward. Just have to substitute R prime with R, right? So R prime himong R, that's why we have this. So, siya ang automatic, nakuha niya ang imuhang Gauss's law in differential form. Gagamit niya ang kaning Coulomb's law. So, kasama siya ang end result, ang formula. Take a look at this, kana, o kani. Right? So, Gauss's law in integral form can be obtained, ito kanina, at integral form, katong E dot dA equals Q enclosed over epsilon naught. By integrating this one over the entire volume V. Okay, so this one over the entire volume V equals katong this one, the surface. And then where this one is equal to this, right? So I have this equation. So from this, ano siya? Okay. So let's have an example. So let's say we have an electric field in some region given here in spherical coordinates given by this expression where A and B are constants. So what is the charge density rho in this case? So we are given with the electric field E equals A r hat plus B sine theta cosine P hat over R. So this is in spherical coordinates. This is R. Let's go back to the question. Our question is if the electric field in some region is given by this one, spherical coordinates by this equation, where A and B are constants, what is the charge density rho? Okay, let's go back. So the charge density rho can be obtained from the given electric field using Gauss's law in differential form. So del dot E equals rho over epsilon naught. Therefore, we can get the rho easily. Ano siya? Del dot E. Okay. So we know the formula sa differential form sa ihang divergence. You can recall sa ato ang previous na lesson sa previous chapter sa kaning sa for this module. We can have this. The divergence formula is given by this. We have 1 over r squared partial r. We have r squared e sub r plus 1 over r squared sine theta partial theta. We have sine theta e theta plus 1 over r sine theta okay. So ito simple na siya nga derivative operation. So i-substitute naman nato ang r squared where ER is E sub r is given by this A over R. A over R plus 1 over r squared sine theta. And the theta component is, do we have a theta component? I think wala. This is 0 plus 1 over r sine theta. P is na naatay EP E sub pi. So we have B sine theta cosine P. So simplifying this one and doing the integration, we have 1 over r squared A sub r na lang siya diha. A sub r, this is not A sub r. R times A or A times R plus 1 over r sine theta partial sa P. We have B sine theta cosine P over R. Asa na ako siya over R dito? for that. And then if we do the derivative, we have E sub naught A over R squared minus epsilon naught B over R squared sine phi. That would be your results in our row. Yes, easy as that. You take the derivative. So that would be our charge density given this electric field. Okay. So we were able to solve this problem. We were able to get the rho or the charge density for this problem by using the differential form of Gauss's law. Now consider a charge distribution rho of R. The electric field at point P generated by this charge distribution is equal to, so this is Coulomb's law, it's our formula, where R is given by this. Oh, dapat kanina last time akong definition sa R is ana man to. Baliktad, dapat kanina siya to get a, para consistent lang sa notation. Anyway, the curl of E, kanina is divergence na to, no? Our is, we get the curl. So the curl of E is equal to this. And we know na ang kaning curl ani, this is actually 0. Because in reality, ang electric field, it's radially outward. It doesn't curl, it just diverges. So wala siya curl. So automatically the value for that is 0. Okay? So although Gauss's law is always true, so one aspect na siya kanina is anak to, diba, the del dot E, balik ka, rho over epsilon naught. However, for the del cross E, for the del cross E, it's 0. One important aspect. Although Gauss's law is always true, it is only useful if you want to calculate the electric field if the charge distribution is symmetric. Kasi, di ba, ang Gauss's law kaya magdepende na doon siya sa imong surface, kung charge niya, or if cylinder siya, right, naka-charge niya, or if surface siya, naka-charge din. So, the symmetry of the imuhang geometry would really simplify the problem. If wala symmetry, then we cannot use Gauss's law. We'll go back to this. Mas powerful gihapon siya because it's more general. Right? So, kani siya ma-solve niya kaya na isolve. But if na-siya symmetry, because most of the time, in nature, na ang symmetry, and we are interested in looking at the symmetry, so we can use the Gauss's law. Because if symmetry, mas simplify ang problem. That's why sa physics really loves symmetry. But later on, ganahan po ng mga physicists na broken ang symmetry because they have makakita at mga useful information. But anyway, so if the charge distribution has a spherical symmetry, then the Gauss's law can be used with concentric spheres or Gaussian surfaces. So, inana siya. Ako charge, tapos pwede ka magamit o Gaussian surfaces as concentric spheres as Gaussian surfaces. If the charge distribution has a cylindrical symmetry, pareani, lines here. So the electric field is symmetric with respect to this. Pwede ko magamit of cylinder, coaxial cylinder as Gaussian surfaces. So pwede ko magamit ana. For plane symmetry, you will use pillboxes. That's what akong gidawin ko ganina. So, pwede ko mo-draw the pill boxes. Okay. So let's look at this example. So use Gauss's law to find the electric field inside a uniformly charged sphere with charge density rho of radius r. So we'll be using the integral form sa imong Gauss's law. So we have the integral of E dot dA. So iyang calculate na ang imong, since take note of the keyword uniformly charged. Find the electric field inside a uniformly charged field. So ano siya? It must be nga imong E is uniform pod all throughout. So constant siya. So this will be constant. Magawa siya sa integral. So we have E dA na lang. Okay? And your dA, since sphere man siya, so katong formula nga r squared sine theta d theta dp. If you integrate that one, you get actually this is 4 pi. So you have 4 pi r squared. That's why na ako 4 pi r squared E of r. So imong electric field is constant, only uniform sa imong radius, but not with the theta and phi, not dependent on theta and phi. So nagawasan sa imong integral. So the charge enclosed by this Gaussian surface is equal to, equal man siya sa Q enclosed over epsilon naught. So we have Q enclosed over epsilon naught. So equal siya ana. But we need to get saan yung Q enclosed, given by this. Ang Q enclosed is, ano ito, diba? Rho theta. But since ang imong rho is uniformly distributed, ano siya? So magawa siya sa integral. We have theta. And this one is the integral over the volume sa sphere. We know say volume sa sphere, right? 4 pi r cubed over 3. Okay. Yan na dayon. Musulod. Right? We have 4 pi r cubed over 3. Then we substitute this one sa right hand side. We apply Gauss's law. We obtain the following electric field. So the electric field, E dot dA is equal to Q enclosed over epsilon naught. Kani siya is mao man siya nga result. Ang kani po paano siya nga result. Equate that to, you get this. I hope it's clear. And then where Q enclosed is given by this. So mag-cancel ang imong 4 pi r squared cancel. Mabili na lang is the rho and then the r 1. Because this is cube, 4 pi r cube, makancel ang r squared sa ubos. So mabili na may r sa taas. So we are just left with pi r over 3 epsilon naught. So this would be your electric field inside a uniformly charged sphere. So take note nga, ang enclosed ni mga charge, small r lang na siya, because that's arbitrary. Okay? You only want to calculate on say electric field inside. But if the question is you want to calculate the electric field outside outside sa sphere of radius r, then the Q enclosed would be 4 pi big R cube over epsilon naught rho, because ang Q enclosed is na-appeal man tanan, right? Tanan. Sa kanina problem, ang ipangita naman is ang electric field inside na din. So kung unsa ang R niya, this is small r, wala ko na ang Q nga na-enclosed. That's why small r na siya gamit nila. Okay, that will be all for our next video. Next part of the video, we will solve these two problems, continuing with the up to electric potential.